Sine and cosine graphs, phase shift and vertical shift. To stretch or shrink a sine or cosine graph, we multiply times the function. But to move the graph left or right, which is a phase shift, and up and down, which is a vertical shift, we add or subtract to the function. This chart of formulas will help you get set up for these graphing problems. So first I have just a general form of a sine function, and where you see A, B, C, and D, there will be numbers. And all of these formulas apply for cosine as well. So the number that's multiplied in front, the A, is the amplitude, how high and how low you'll go. The period of the function is 2 pi divided by the B value, and that will be the fourth number on your scale. And then to get the other three numbers, you multiply by a fourth, a half, 3/4. So you'll have four numbers on the positive side and four numbers on the negative side to define your scale. Then the phase shift, which is moving left or right, is found by taking C divided by B. If there's a plus in front of the C, you'll move to the left. If there's a minus in front of the C, you'll move to the right, which is kind of backwards of what you would think. And then finally, a vertical shift, which is up or down, is represented by a number added or subtracted at the end outside the function. If it's plus, we move up. If it's minus, we move down. And remember, a negative in front of the whole thing means the graph gets flipped over. So we start with the function f of x equals 1.5 sine times 2x minus pi. And I've labeled what would be A, B, and C, so you can match that up with the formulas. The amplitude is 1.5. The period is 2 pi divided by B, which is 2. And so the period comes out to be pi, and remember that's going to be the fourth number on your scale. Then the other three numbers, you multiply pi by a fourth, a half, and 3/4. So we have pi over 4, pi over 2, 3 pi over 4, and then finally pi. Phase shift is C divided by B, so pi divided by 2 is pi over 2. Because there's a minus in front of the C, we'll move the graph to the right. There's no D value, so there's no vertical shift. You need to write out all of this list for every single problem. You need to have everything listed just like that, all work shown. Now to draw the graph, first we put on the scale. You always save the amplitude for last. But we'll go ahead and put the scale on. Pi over 4, pi over 2, 3 pi over 4, and pi. And then do the negatives on the left. Now, the phase shift says pi over 2 to the right. According to our scale, pi over 2 is 2 marks over from 0, 0. So everything will move 2 spots over to the right. That includes the y-axis. So we're going to draw a new y-axis. And then each one of our scale marks moves 2 to the right. I'm starting at the far left at negative pi. So that moves 2 to the right to here. And then negative 3 pi over 4 moves to here. Negative pi over 2 to here. And negative pi over 4 to here. I already moved the y-axis. Positive pi over 4 would move here. Pi over 2 to here. 3 pi over 4 to there. And pi to there. In general, what I just remember is after I move my y-axis, then I need to highlight 4 marks to the right of that y-axis and 4 marks to the left of the y-axis so we can keep our pattern. We're not moving the graph up and down at all. So now we have a new 0, 0 right here. That's our new origin. The amplitude is 1.5. So I'm going to go back to the original y-axis. and 1.5 would be in between the 1 and the 2. So let's go to the new y-axis and kind of mark that off. Here would be positive 1.5, and here would be negative 1.5. So that's as high and as low as our graph's going to go. Now that we have our new scale, we can draw our graph. This is a sine graph. Sine graphs in the middle are at 0, 0. And then when you go to the right, they go to their highest point. Then they cross, go to the lowest, and cross again. And then on the left side, they go to the lowest, they cross, highest, and cross again. So I still have drawn 2 periods worth of this graph. It just got scooted over to the right, a distance of pi over 2. It's difficult to make these look nice. Just do the best you can. It's helpful to have multiple colors. This next graph is y equals negative 0.5 cosine of 1/2 theta, and then minus 1. Notice the minus out front, so this graph flips over. And if I label, 0.5 would be A, the 1/2 would be B, and the 1 on the outside would be D. I know it's D and not C, because C is always trapped inside of parentheses. And then D is always outside of the function. So minus 1 is the D, or just 1 rather. So my amplitude is 0.5, my period is 2 pi divided by 1/2. Remember, when you divide fractions, you flip and multiply. So that's 2 pi times 2 over 1, which is 4 pi. That's going to be the 4th number on my scale. And then multiply 4 pi by 1/4, 1/2, and 3/4, and I get the other 3 numbers on the scale. There's no C value, so the graph will not be moving left or right. The D value for the vertical shift is 1, and because it's minus, that means we're going to be moving down 1. So I start by putting on my scale. Pi, 2 pi, 3 pi, 4 pi, and then the negatives on the other side. I'm not moving anything left or right, but I am moving down 1. So, let's put some marks here. If the whole thing is moving down 1, that means the x-axis as well is moving down 1. So I'm going to draw a new x-axis that has been scooted down 1. And then all my little scale marks will also be moved down 1. So I'll just go straight down and copy those onto my new x-axis. 4 on the left side, 4 on the right side. And here is my new 0, 0. My amplitude is 1/2. So from my new 0, 0, I know the highest I'm going to go is up 1/2, and the lowest I'm going to go is down 1/2, counting from my new 0, 0. Now everything's marked off. I'm ready to draw the graph. Cosine graph normally in the middle starts at its highest point, but this one's flipped over, so it starts at its lowest point. Then it crosses, highest, crosses, and lowest. Then on the left side, it's going to go crossing, highest, crossing, lowest. So there's our cosine graph, and it's been scooted down 1. Now we have y equals 4 cosine of 3 pi x minus 2. So 4 would be the A. Whatever's in front of your variable is B. Pi is not a variable. It's part of the number 3 pi. So B is all of 3 pi. I know the 2 is D and not C, because C is trapped inside of parentheses, always. So the 2 is D. So making my list, and again, always write all of this stuff down. The amplitude is 4, period is 2 pi divided by 3 pi, which is just 2/3. Most of your homework problems will have pi in them for the scale numbers, but they don't have to. So the fourth number on the scale is 2/3. We multiply by a fourth, a half, and 3/4, and your other three scale numbers are 1/6, 1/3, 1/2. There's no phase shift. The vertical shift is 2. Because if it's a minus, it's down 2. So we start with the scale. 1/6, 1/3, 1/2, and 2/3. And then the negatives. Oops, negative, negative. And the whole thing has moved down 2. So let me just mark off some places here. So my x-axis is moving down 2. There's my new x-axis. My little scale marks will also move down 2 onto the new x-axis. And here's my new 0, 0. The amplitude is 4. So from my new 0, 0, I know the highest I'm going to go is up 4, and then the lowest is down 4, right there. And we're ready to graph. It's a cosine graph, so in the middle, I know that I start at the highest point, which is 4, up 4. It's actually at 2, but it's up 4 from my new 0, 0. So I'm at the highest, cross, lowest, cross, highest. And then on the left side it would cross, lowest, cross, highest. Okay, let's do one more. Y equals negative sine times theta plus pi over 2. The amplitude would be, well, first of all, the graph is flipped because of the minus. The amplitude would be this invisible 1, and b would also be an invisible 1. The pi over 2 would be c because it's trapped inside the parentheses. So my amplitude is 1. Period is 2 pi divided by 1, which is just 2 pi. That's the fourth number on the scale, and that's the parent graph scale, which is pi over 2, pi, 3 pi over 2, and 2 pi. Then this one has a phase shift. Phase shift is c divided by b, so that would be pi over 2 divided by 1, which is just pi over 2. It's moving to the left because there's a plus in front of the c. So putting the scale on, you have pi over 2, pi, 3 pi over 2, and 2 pi, and then the negatives, negative, now my graph is moving to the left a distance of pi over 2. According to our scale here, pi over 2 is just one scale mark over. So my y-axis moves one scale mark over to the left, to pi, negative pi over 2, so that's my new y-axis. And then everything else just moves over one space. And remember, you have 4 to the left of your y-axis and 4 to the right. 2, 3, 4. I'm not moving up or down, so here is my new 0, 0. And let's mark off some spaces here. Now my amplitude is 1, so from my new 0, 0, I know I'm going to go up 1 and down 1. This is a sine graph. Sine graphs always start at the origin, so here's my new origin. Here's my new dot at 0, 0. And then normally when you go to the right, it goes up, but this one is flipped. So when I go to the right, I go to the lowest, and then cross, highest, and cross. On the left side, that would now go to the highest, cross, lowest, and cross.